Hello students, let us look at a problem of Fourier series expansion. So here we have been given a signal x of t in which x of t is basically a half wave rectified waveform. Half wave rectified waveform meaning that it's a waveform output of a half wave rectifier. As you can see, this is basically a sinusoidal or a sine wave because it is 0 at t is equal to 0, and then it basically goes up, and the second half basically is from pi to 2 pi, which is actually missing. Okay, now based on this, based on the equation that we have seen previously, that is these equations, let us try to define x of t. Now x of t, as you said, we have to find what is a naught, a n, b n for different values of n, where omega naught is basically dependent on the period t of the signal. So period t is very important because based on that only we are able to write this equation. So we will, using this formula, we will do the problem one by one. So the first thing is we have to define the equation. So x of t is basically some equation which is a sinusoidal wave. So I will write sine, something has to come here, for t going to be between 0 to pi. So between 0 and pi, and then from from pi to 2 pi it is 0. So for t from pi to 2 pi it is 0. Okay, so this is what is it. Now what is inside, what is going to come inside? So let us look at this wave. We know that it is sine. What is, generally when we write a equation, we write it as sine 2 pi f t, correct? Now what is the frequency here? Frequency is generally 2 pi, f is 1 by t, correct? So what is the time period here? As you can see, the period is going to, the signal is going to repeat itself within this period. Am I correct? It is going to repeat itself within this period. And the height of the wave is a, correct? So a sine, okay, so a sine 2 pi by t small t, where I can say that it is going to be a sine, now time period t I already told here, it is 2 pi because the signal is repeating after 2 pi, correct? So it is 2 pi divided by 2 pi into t, where 2 pi and 2 pi cancel and we'll get a sine t. So the first part is a sine, and here I will write t, a sine t. So this is my equation of the wave x of t within a period. So the rest of the things I will just cancel out because this is something that you should be able to write every time. So within a period, so within a period, in a period, x of t is basically this. If that is the case, then obviously I have to write t also, where capital T time period t is 2 pi. Okay, then what all part we want to look into the equation. See, we should know what is omega naught. Okay, we should know what is omega naught. Here and here we require t, already we know. So omega naught we require. So what is omega naught? Omega naught is basically, omega naught is 2 pi f naught, where 2 pi f naught is 2 pi by t, correct? So it is 2 pi by t, 2 pi by 2 pi, correct? Because t is 2 pi. So omega naught is equal to 1. Now based on this we have to write the equations. Sorry. So first I will write a naught. A naught is equal to integrating, correct? So I will write a naught. A naught is integrating from T naught to T naught plus T. That is what we have studied, correct? T naught to T naught plus T. So what is T naught here? So we can see that the signal starts at 0 and goes all the way up to 2 pi. So I will write from 0 to 2 pi. So from 0 to 2 pi. And then I have missed out 1 by T in the front. So this one I have to write, correct? So this is the equation that I am trying to write. So 1 by T also I will have to write. So let me write it anew. So 1 by 2 pi, which is T, integral, or first let me write the equation itself. The equation will be 1 by T integral T naught to T naught plus capital T x of t dt. Correct? That is the equation of A naught, x of t dt. Which in our case it is going to be 1 by 2 pi integral 0 to 2 pi. X of t is basically this equation. So right now I will write x of t here. I will put the remaining portion in the next session. Dt, okay. So next I will write is equal to 1 by 2 pi. Okay. Now this 0 to 2 pi I have to split up into two parts because this itself is split up into two. So I will write first, it is going to be from 0 to pi. The signal is a sine t dt, and then the remaining portion is from pi to 2 pi, and that signal is 0 dt. We know that the integration of 0 is going to be 0. Correct? So I will write 1 by 2 pi integral 0 to pi a sine t dt. Correct? Now therefore a naught is going to be 1 by 2 pi, that is there, sorry, 1 by 2 pi, that is there, and then the integration of a can be taken outside, so I will write a here itself. Okay, then whatever is the sine integration of sine will give me minus cos, correct? So minus cos t, and the limit is from 0 to pi, which we know is a divided by 2 pi into minus of cos pi minus of minus, which is plus cos 0. We know that cos pi is minus 1, that we know. So minus of minus 1 is going to be plus 1 plus cos of 0 is again 1, so we will get 2 there. So this I will get as a divided by 2 pi into 2, which gives me the answer as a divided by pi. So this is a naught. Similarly we will have to find out an for different values of n. So I will keep that n as such, and I will write for different values what would be an. So an is, again looking at the equation, it is 2 by t. So 2 by t and limit t0 to t0 plus capital T xt cos n omega naught t dt. Xt x of t cos of n omega naught t dt, which is basically 2 by 2 pi, because capital T period is 2 pi. Then again the limit is going to be 0 to 2 pi x of t cos n omega naught t dt. Correct? From where again a of n I will write, 2 and 2 will cancel, so 1 by pi will come out, and then the remaining 0 to 2 pi I can split it up into two parts, because x of t as given here, is of two different parts, so that I have to take care. So I will basically write from 0 to pi, it is going to be a sine t cos n omega naught t dt, plus then from pi to 2 pi 0 into cos, which is again going to be 0 dt. So it's as good as the second integration is not there. What remains is, again I have to write an is equal to 1 by pi. Now coming to this integration, a I can take outside, so I will write a here, and now the integral, only one integral is remaining, so 0 to pi sine t cos n omega naught t dt. Correct? We know that sine a cos b is basically sine a plus b minus sine a minus b. So based on that, I can write an is equal to a divided by pi integral 0 to pi. Now sine, you can write anyone on the front. But before that, I should remember that omega naught, already we have found out omega naught to be 1. So that I will substitute here so that the equation becomes somewhat more simple. So it is cos nt dt. Now if I am going to apply this one here, so sine a cos b is equal to sine t plus nt. T plus nt can be written as 1 plus n t. Okay, and then minus sine of a minus b. Not minus, it should be plus. So it is plus sine of a minus b, which I can write it as t minus nt, which is 1 minus n of t. So it is 1, write it, sorry, 1 minus n of t. Okay, that within the bracket, into dt. Okay, which I can again split it apart into two portions. So it is an, a by pi is common, that I am not going to change, and then I am going to write two integrations. One is from 0 to pi sine 1 plus n t dt, plus the second is from 0 to pi sine 1 minus n t dt. Okay, now if I am going to integrate sine, obviously I will get cos. This is something that we all know. Integration of sine will give minus cos. So that if I am going to do, then I will get the answer as an is going to be equal to a by 2 pi, that is there, correct? And then the remaining portion I can write it as, so it is going to be integration, it's going to be minus of, minus cos 1 plus n t divided by 1 plus n, correct? Then the limits of that have to be from 0 to pi, plus the second one is again minus cos 1 minus n t divided by 1 minus n, and again here for t the limit is going to be from pi to 2 pi, sorry, the limit is same, 0 to pi, 0 to pi, let me write pi properly, from 0 to pi. So here I will get an is equal to a divided by 2 pi, and within brackets I will first write, so let me write this one as a bigger bracket, okay, and then this one will be minus of cos 1 plus n pi minus of minus plus cos of 0. I'm not going to write 1 plus n because it's one and the same, so cos of 0 divided by 1 plus n, then plus the remaining is again minus of cos 1 minus n pi minus of minus plus cos of 0 divided by 1 minus n. This is the second part, correct? Now something very important. See, you should know that cos of 0 is 1, cos of pi is minus 1, cos of 2 pi is again 0, cos of 3 pi is again minus 1, so 1 minus 1 1 minus 1. So you can see with respect to 0, if you look at the number that is multiplying the pi, which is, in this case it is 1, here it is 3, correct? In those cases the answer comes out to be minus 1, correct? Whereas in even cases the value comes out to be positive 1, so plus 1. So if that is the case, then I can very easily say that cos of 1 plus n into pi, its value will basically depend on 1 plus n. If 1 plus n is odd, then it is minus 1. If it is even, then it is plus 1. In that case, I can write minus 1 raised to power 1 plus n, because if 1 plus n becomes odd here, if this number is odd, obviously this value comes out to be minus 1, and if this is even, you can see that this value comes out to be plus 1. So in a way I can write this equation as this equation, and that is what exactly we are going to do. So cos of 0 is 1, that we all know. So I will write, let me rub this one also. So I will write a of n is equal to a divided by 2 pi, and then limit, then minus of cos can be written as minus of minus 1 1 plus n then cos 0 is again 1, so plus 1 divided by 1 plus n. Similarly, plus this one can be written as minus of minus 1 minus n plus 1 divided by 1 minus n. Okay, so that part I have done. Now what I will do is I will take minus commonly outside. No other reason, it's just that I am trying to simplify it as much. So an is basically minus of a by 2 pi. When we take the minus outside, it becomes minus 1 into 1 plus n minus 1 divided by 1 plus n, plus here also I will take minus 1 outside, so minus 1 raised to power 1 minus n plus 1 divided by 1 minus n. Okay, now here something very interesting you can note, that is that for n is equal to odd, that means when we are saying that n is odd, then obviously 1 plus n will be even. Okay, so if it is even, we know that minus 1 raised to power an even value is always going to be 1, correct? So based on that, for n is equal to odd, what you will find out is that an comes out to be minus a by 2 pi, and then this one becomes plus 1, so 1 minus 1 divided by 1 plus n, and then the second part becomes 1 plus 1 divided by 1 minus n, out of which the first part basically becomes 0. This becomes 0 because 1 minus 1 is equal to 0. So this becomes 0. The second part becomes 2 divided by 1 minus n. So I can write this as minus a divided by 2 pi into 2 divided by 1 minus n, from which I can very clearly say that therefore, let me put that in slightly bold, then therefore an is going to be equal to minus a divided by, 2 and 2 gets cancelled, 1 minus n pi. So this is the value of an when it is odd. Okay, so when it is odd, so I have to not forget, when it is odd. Wait, let me check out something. Okay, if I am going to take minus 1 outside, yeah, there is a mistake that I have done here. When I took minus outside, here it was minus 1, here also it was minus 1. So I forgot that. In that case, this will be again minus 1, and because of which this turns out to be 0. Sorry, this turns out to be 0. Therefore, an is equal to 0 for n is equal to odd. And what about when it is even? So for n is equal to even, so when we are talking about even, an is equal to, now this equation becomes minus a divided by 2 pi into, so when it is even, so we will get 1 plus n as odd, and odd of minus 1 is going to be minus 1. So based on that, I will get minus 1 divided by 1 plus n, and plus minus 1 divided by 1 minus n. So I have to put the curly brackets, from which I will get minus a by 2 pi and minus 2 by 1 plus n plus minus 2 by 1 minus n. Correct? And from that I can write, therefore an, let me take this, therefore an is equal to 2. I can take out commonly from this and it will cancel out from the 2 in the denominator, and minus also I can take out and it will make the minus a as plus a. So plus a divided by pi into 1 divided by 1 plus n plus 1 divided by 1 minus n. If you would cross multiply, you will see 1 minus n plus 1 plus n divided by 1 square minus n square, where this minus n and plus n gets cancelled and you get 2 on top, and the denominator you get 1 minus n square. So I will basically write this is equal to a divided by pi into 2 divided by 1 minus n square. Okay, so based on that I can write, therefore I have to write totally an is equal to 2 times a divided by pi into 1 minus n square, and this is for n is equal to even. This is an. Similarly, we have to calculate for bn. So this is all, total calculation is a naught we have completed, an we have done, so then we have gone down, we have to now do for bn. Bn, again the equation is similar, the only thing is it is sign. Okay, so I will write next bn the equation is 2 by t integral t naught to t naught plus t x of t sine n omega naught t dt, from which I can write bn to be equal to, capital T is 2 pi, so this becomes 1 by pi, then limit is from 0 to 2 pi, x of t I will write as such, in the next step only I will split it apart, and then sine n omega naught we already said is 1, so sine nt dt. And what is the value of x of t? So based on that I will have to again split this one up. So bn is going to be equal to 1 by pi, and within bracket I will get from 0 to pi, it is going to be x of t is going to be sine t, correct? It's sine t sine nt, and then the other part is 0, so I'm again not going to write that, so let this be like this, where obviously sine and sine we already know the equation, sine a sine b is cos a plus b minus cos a minus b. Sorry, it is cos a minus b, and so I will rewrite it cos a minus b minus of cos of a plus b. Sorry. So this is what is my sine a into sine b. So I am going to use that formula, and I will write 1 by pi integral going from 0 to pi, and now I am having cos a minus b, which comes out to be 1 minus n t minus cos 1 plus n t. Okay, and then bn turns out to be 1 by pi, and now if I am going to integrate the whole equation, then you can see cos, the integration of cos becomes sine, so it is sine 1 minus n t divided by 1 minus n, with limit going to be from 0 to pi minus again this one will be cos integration becomes sine, so sine 1 plus n t divided by 1 plus n, and it is again going to be from 0 to pi. Now if I am going to look b of n, b of n is equal to 1 by pi, and now here it is going to be sine 1 minus n pi minus sine of 0 divided by 1 minus n minus sine 1 plus n pi minus sine of 0 divided by 1 plus n. Correct? And from here now I can put the value of sine 1 minus n. So there also I will look for the even and odd. If there is any difference, for example, we know that sine of 0 is 0, sine of pi is also 0, sine of 2 pi is also 0, so it's all going to be 0 whatever be the case. So I can write, but sine of n pi, or when n plus 1 pi, 1 plus n or 1 minus n, or any number pi, I will write basically sine of n pi, because any number pi is equal to 0 for n is equal to 0, 1, 2, you take any number, and even even plus minus 1, so I will write plus minus 1, plus minus 2, in all these cases sine of n pi is going to be equal to 0. Therefore I will get b of n is equal to, b of n should be 0. But is it 0? Because there is one case which is left here, and which is when 1 minus n turns out to be 0. Okay, in that case you will get in the numerator also as 0 and in the denominator also 0. And that is where the trouble actually comes, because you are now having 0 and 0. So for all values of n where the denominator does not become 0, it is all okay. The answer will be perfectly 0. But for value of n is equal to 1, you are having an issue. So what I will do is, I will say that this is okay, b of n is equal to 0 for all n except for n is equal to 1, because for n is equal to 1, what I will get is b of n is equal to, so what happens at n is equal to 1, let me again explain it. If you look at the previous equation, then you will see that there is a sign 1 minus n divided by 1 minus n, okay, and this at n is equal to 1, this turns out to be 0 divided by 0, and that we cannot allow because 0 divided by 0 is undefined. Therefore we use L'Hospital's rule, and L'Hospital's rule says that if you are having such a case, then you have to differentiate both the numerator and the denominator. Therefore I will differentiate with respect to n sine of 1 minus n pi divided by differentiate with respect to n 1 minus n, and you know that the differentiation of this one will turn out to be cos 1 minus n pi into cos 1 minus n pi into minus of pi, okay, if you are going to differentiate it with n, and then in the numerator we will get minus 1, and this we have to do. Therefore at n is equal to 1, what we are having is cos of 0 into minus 1 divided by minus 1, sorry, this is minus pi divided by minus 1, cos of 0 is again 1, so this turns out to be pi. Therefore from the initial equation shown here, the b of n is basically, you know, given by this equation, where this part will become 0 at n is equal to 1, but this part at only n is equal to 1 will give me the value that I have just now got. Here I have forgot something. If you remember, it was a, so that a I have to take outside and I have to write here, sorry, that a I am going to write out here, you should also write. So what remains is this completely becomes, according to the, you know, just now concluded, we get that as pi, isn't it? Therefore b of n can be written as a divided by 2 pi into pi, which gives me a by 2, and that also only at n is equal to 1. At all other values, its value comes out to be 0. X of t is, according to the equation that we have already studied, it is basically given by this equation, where we have already found out what is a naught, an and bn. So I will write x of t, or let me write it in this way because I'm doing it for the first time, where a naught, we just now found out a naught to be a by pi. If you remember, we first solved for a naught, it was this one. We first solved for a naught, and a naught we found out to be a divided by pi. And the second one was an, where an we found out to be, having two values, for odd a particular value, for even a particular value. Correct? And finally we have found out bn to be for only n is equal to 1. For a naught we have found out it is a by pi. For an I will write an is for only n is equal to even values. Correct? So I will write summation n is equal to even values up to infinity, okay, or we can write in this way also, that n is equal to even as well as n is equal to 2 to infinity. So in this way it will be okay. And if we are going to look at only the even values, we got the answer as 2a divided by pi n square minus 1. Let me have a look here. Pi divided by pi into 1 minus n square. So 1 minus n square, okay. And in bn we only found out for n is equal to 1, so I will write only b1, and that is basically a by 2. Therefore finally, if I had to write x of t, I will basically write, let me write it in blue. So x of t is first x a naught is a by pi, plus this second part, which is summation, and we know that for an it's only even values, so I will write summation n is equal to 2 to infinity and n is equal to even, this is the second condition, 2a divided by pi into 1 minus n square plus summation n is equal to 1 to infinity. It is not there, only one value is there, so I will write only one value, which is b1. So I will get a by 2, sorry, I will change the color, a by 2 into, now here omega naught is already 1, that we already know, n we already said only b1 is there, so only n is equal to 1, so what remains is sine t. And this is basically the Fourier series representation of the half-wave rectified waveform. Half-wave rectified waveform. Now you might see that it's a very lengthy problem. One way to reduce is to go from trigonometric form of Fourier series to exponential form, and that we will do in the next class. And then you will find out that it's not as difficult as the case of trigonometric form. Trigonometric form is slightly difficult to get. So Next class we will do the exponential form. There you will find that it is much easier. Thank you.